The horizon, it's all just perspective. Part 1, perspective and the horizon. Everything that we see through the eyes of perspective. Everything from high goes down to low, everything from low goes to high. Here we see an example in World War II photo, all the planes and ships, low to high, high to low, convergence at the horizon. Everything converges to the horizon. The horizon is the highest visual point of the surface that you can see. Few questions. Objects in the foreground will always appear lower in your vision compared to objects as they get closer to the horizon. Objects on the horizon will always appear to be in the highest visual position. Objects beyond the horizon will do exactly the same things as the objects in the foreground, and they will now drop below the horizon just as the objects in the foreground did. They drop below the horizon. Everything obeys perspective. There is nothing that we can see that does not obey this. We can literally tell which of these objects are closer and which of these objects are further away just by how high they are in relation to the horizon. People looking from that jetty over there, looking the other direction, will be seeing this the exact opposite way around. So everything that we look at obeys this. Lower, the closer it is to you, and higher the further away. There is nothing that you would be able to show. I challenge you to find something that does not do this. Millions of examples could be given. Now we move on to the horizon, rising with the observer. Here we have a video. I'm on the jetty, camera is well above definitely above the railing. I lower the camera, below the railing, above the railing, below the railing. Clearly the horizon is rising with the observer, but there is more. Here we have ships. We can tell that the observer is above these ships, because if the observer was below the ships or in line with the ships, we would see it more like this. So we know that when we see this, the observer is above the ships. And here we have these ships here, and we can tell that the observer is probably somewhere around here, and the horizon is cutting straight through them all. Maybe the observer is here. Hard to tell exactly, but we know that the observer is not at base level, and we know that the observer is not above them. Here we have a much lower observation, and how do we know it's lower? Because we can see the horizon just through the ships there. Okay, here we know that the horizon or the observer is well above these ships as the horizon is well above them. Now we go to an even higher position. Now we are probably many thousands of feet above these ships, and we can see them all lined up all the way to the horizon in the distance. Objects disappearing below the horizon. We have two ships, a small sailing boat and a large general cargo ship. We notice they are both doing the same thing. Both ships are appearing to drop below the horizon the further they get from the horizon. I will now describe both observations using the same wording. As the ship goes beyond the horizon, we begin to lose the bottom of the ship. As it moves further away from the horizon, more of the ship appears to be dropping below the horizon, until eventually it will drop completely under the horizon. We see a perfect mimicking of what happens beyond the horizon happening in front of the horizon. They are the same thing. This is the main reason that ships disappear beyond the horizon. From there, we then need to take into account angular resolution and Rayleigh's criterion. Here we have a ship I filmed the other day. We see that it's clearly well below the horizon, and as it moves towards the horizon, we see the ship's hull become visible. Once it reaches the highest visual point, which is the horizon, it then starts to disappear into the inferior mirage. Here we have two different days, two different sailing boats. One's just past the horizon. It is well out of view now. It's starting to get right out of view. We can see that the buoy is right there at 3 miles away in the bottom picture. When we go even closer to that, we see now that the horizon is well beyond that buoy, and the sailing boat in the background is not even actually on the horizon yet. That horizon is many miles past that buoy, whereas beforehand the buoy was right on the horizon. I have had mirror tests from this location here, from a 2-foot mirror to a 5-foot observer. So now we're going to do a quick comparison between these two observations. We notice here in the first one the buoy is on the horizon. To now make them the same, we need to add some water and add a buoy. If we take the water away, notice how high the buoy appears to be? This is the difference that a closer horizon or a further away horizon can make. It has nothing to do with the actual land moving, it is the horizon itself moving. So now we're just going to quickly go back over some of those boats we were looking at earlier. I want you to picture an observer on the opposite side of the horizon, equal distance from the horizon, and equal observer height. This is how these observations would look to them. All of these boats and ships would either be completely covered or partially covered by the horizon for that observer looking back towards them. Part 4, the distance to the horizon changes. Remember, the horizon is the highest position that we can see the surface. Everything on the horizon will look higher visually than everything in front of the horizon and everything behind the horizon. As the horizon moves position, everything else adjusts accordingly. Here we have a comparison of 5 different days, and as the days go on you notice the land becoming more revealed until eventually we can see down to the shore. It is the horizon that is moving, the land is not lifting or sinking. And here we have a comparison of 16 days where you see the buoy is at a different distance relative to the horizon. Now we have a rock wall at semaphore. The rock wall is 3.6 miles away. Here we see the horizon is many miles beyond the rock wall. You can see the rock wall is below the horizon. And then as we go through different days, you see the rock wall eventually get to the point where it is on the horizon, and you can no longer see any water in the background. Last but certainly not least, we get to this, and the question of why do the oil rigs appear to be at different heights on different days? What have we learnt so far? Everything on the horizon is in the highest visual position that you can see the surface. Everything before the horizon will appear below the horizon, and everything beyond the horizon will also appear below the horizon. The oil rigs are just doing exactly what perspective dictates. As you can see with the buoy and the jetty in the background, to the very right we see the jetty is well below the waterline and the buoy. The buoy is on the horizon and appears to be much higher than the jetty, which is not seen at all. In the middle photo we now see that the horizon has moved to the reef, and we see water between the buoy and the horizon. The buoy has now become lower below the jetty, and then to the very left we see the jetty is now well above the buoy, and the buoy is now well below the jetty. Whereas in the top right hand picture, the buoy was at this height in comparison to the jetty. These three observations show you exactly what's happening during this observation that Zanuck has provided. The oil rigs are not lifting up over a curve. We just have a horizon that has moved further distance, and then all objects need to obey perspective. And all that's left now is to sail into the sunset, and we are done.
Thank you. Come again.